we will derive the formula for average or mean value of alternating current. Okay, so I will straightforward focus into the derivation, nothing more. So in order to understand that, we first need to draw the graph. So let me take time t and then current I in the y-axis, or you can take voltage V, because current and voltage both will have the same mean or average, same type of average, right? So we know that the graph will be a sinusoidal graph. Okay, the graph of AC is a sinusoidal graph. So you have a peak which is I naught, and you have a point which is the lowest point, which is minus I naught, and this is a sine curve. As this is a sine curve, so we can write I in terms of sine omega t, and so I becomes I naught into sine omega t, right? Here, see, I is the current which is basically fluctuating, which is not fixed. I have the fluctuating value. See, it is increasing and then it is again decreasing and then increasing and then again decreasing. So it has this fluctuating nature. I naught is the maximum current, here, which is this value, and t is what we know as time. T is time, and omega is what we call angular frequency. So what does omega mean? Omega means, if you have a larger omega, that means there would be much higher frequency, meaning that this loop will be completed in a much shorter amount of time. Okay, so this would be more denser in that case. So in less time you have more frequency. Okay, so now we focus into the derivation. So an interesting question that might pop into your head, that is, why did they take the limit from 0 to t by 2? You have to look into the graph for that. You see, the sine curve have this nature. It has this nature that it starts from 0 and then goes all the way to a peak point and then goes back again to 0 and then a lowest point, then again goes to 0 and then again to the highest value. So this is I naught, as I have discussed earlier, and this is basically minus I naught, right? So if you take integration from 0 to t, this is 0, this is t by 2, this is t. So if you are to take integration from 0 to all the way to t, the problem is that this area, let's say this area is 5. I don't know the value, but I'm just guessing. Okay, and this subsequent area is, then it will then come out to be minus 5, which is interesting. If this area comes out to be 5, then this will come out to be minus 5, and when you add these two, you get nothing but 0. So if you take from integration from 0 to t, because of the symmetry of this, so this plus half is symmetric with this minus half. This half cycle is symmetric with the other half cycle. So as they are symmetric and they are opposite, they are anti-symmetric. That's why they together, if you integrate from 0 to t, you will get the result to be 0, and that is not helpful. That's why in order to find out the average, we take only the half cycle. We take from 0 to t by 2 or t by 2 to t. We can take from t by 2 to t. So if you take from 0 to t, you might get 0. So that is why we avoid integrating from 0 to t. We take 0 to t by 2. So we want to find out the average. We want to find out the average of current. That's why we multiply current with the differential element of time, and then we take the integration from 0 to plus half t by 2. And as we want to find out current, we cannot divide by current, we have to divide by time. We take dt, integration of dt, and within the same limit 0 to t by 2, which we have taken in the numerator. And I hope that makes any sense to you. That makes some sense to you. So you have this variable t in the x-axis and this variable I in the y-axis. So when you take the integration, you multiply x with y, because you know that area of a rectangle is length times breadth, right? So my length is, let's say my length is I, and my breadth is this small value of dt. So my length is, let's say I, which is this value, and my time is my breadth, so which is this value, which is the value in x-axis. And I take a very small section of, let's say I rewrite it, okay? I take a very small section of I cannot take a larger section. I take a very small section of I, and the time that it takes to cover this I is this time, which is basically dt. And I multiply this I with my dt. So I is in the vertical direction and and dt is in the horizontal direction. If we multiply I with dt, we get this area. So if we take the integration from 0 to t by 2, we get the whole area. That is the concept. Here. Okay. So you divide, as you want to average it up, as you want to find out the mean, you divide it by the time, not by current, because you want to find out the average of current, so you don't divide it by current, okay? So now the rest is just simple mathematical calculation. I hope you understood the physics behind it. So now you have what we call I equal to I naught sine omega t. Just plug in here. Okay, let me do it for you. Okay, so I have I average, which is this value. Okay, let me okay, so I have I average, which is basically I naught sine omega t, and then take the integration from 0 to t by 2, and then you have to take the integration of dt again from 0 to t by 2. Now my I naught is a fixed value. The highest value is always the fixed value, right? Maximum value or highest value, which is the peak value of current. And you can take peak value outside of the integration, as it is a constant. So you can take it outside. And this value right here, dt, if you take the integration of dt, you get simply t. So I get t within the limit 0 to t by 2. Now that I have that, I can take, okay, let me use another color. I can take I naught, and see from here you get t by 2, right? Because you put okay, why do I show it? So you put t by 2, and then you put 0, right? So this is simply t by 2. So I have t by 2 here. So that would be t by 2, and I have this integration. We know that integrating sine will simply give me minus cosine and omega t, and t is the very okay, there is a problem. I don't have the okay, I missed dt. It looks like I missed dt. Extremely sorry. Okay, so I integrate with respect to t, so omega is my constant, and I must divide by that. Constant means coefficient. I must divide by that coefficient omega, right? Omega is here, is a constant. So it would be out of that. So now you have I naught divided by t by 2. I can take this 2 in the numerator. So I have 2 I naught divided by t, and then this whole thing, and I take minus outside, I take omega outside. So I have basically 2 I naught omega t, and then cos omega t integration from 0 to t by 2. Okay, so I wrote the whole thing here because it were looking all messy. Okay, so now you have minus 2 I naught divided by omega into t, and then you have this t by 2. You plug in t by 2 here, right? So remember guys, omega is 2 pi divided by capital T. So omega is 2 pi divided by capital T, and my small t here is capital T by 2. Okay, that is my upper limit. Now for the lower limit, you have 0. You plug in 0 here, it becomes 0. So you have cos 0. So now I have 2 I naught omega t, and then t divided by t, I have 2 divided by 2, I have cos pi, minus this cos 0 is simply 1, and cos pi is minus 1. Okay, cos pi is minus 1. So 2 I naught divided by omega t, I have minus 1, then minus 1. So basically I have minus 2 here. So okay, so I can write minus times minus is basically plus 4 I naught divided by omega times t. Remember guys, omega is nothing but 2 pi by t, right? It is 2 pi by t. So my t, okay, so my t cancel each other out. I have 4 I naught divided by 2 pi. Hence I have 2 divided by 2 divides 4, and I have 2 here. So I have 2 I naught divided by pi. That is my average value. The things that I have said here, this is just some mathematical calculation. You can do it if you are confident enough. You can do it yourself. So this is the average. So let's check out. Yes, it is indeed 2 I naught divided by pi, and if you take a calculator, you divide 2 with pi, you get 0.637. Okay, so that this is the average value. I average is 0.637 I naught. I naught is the peak current, is the highest current or peak value of current. So we found the average for a half cycle, right? I told you earlier we found average for half cycle, first half cycle. So if we were to find out for the other half cycle, we would get minus 0.637 I naught. So there you go, you have current for the first half, which is 0.637 I naught, and for the second half you have minus 0.637 I naught. So for the full cycle, if you add these two, you get 0. For the full cycle, the average or mean of full cycle, complete cycle, is basically 0, because you just simply add them and you get 0, right? So that's all. For the complete cycle it is 0, and for the half cycle it is 0.637 I naught. Subscribe to my channel for more videos. See you in the next video.